Hi, today I'm going to be covering two optimization questions, but before I get into those two questions, I'm just generally going to go over the steps on what you should do on covering optimization problems. So first you would want to define your variables for the unknown values. Then you want to write the equations you want to maximize or minimize. Then write the restriction equation for the given information. Then solve the restriction for one variable and substitute it into the main equation. Differentiate the new equation and set the equation to equal to 0, and then solve for variables and the remaining values and check restrictions and answers. So this is the general steps on what you do to solve optimization questions. The hardest part is usually figuring out the equations, like knowing the formulas and such. But once you figure out the equations, everything else will be easy. Now I'm going to get into the question here. The first optimization question is asking about a Norman window, which has the shape of a rectangle with a semicircle on top of it. If the perimeter of the window is 20 feet, that's the amount of material we have. Find the dimensions of the window so that the greatest possible amount of light is admitted. So now it's saying that we need the maximum possible area. That's basically what it's asking. Okay, so let me just draw a quick diagram here, just so then we can visualize what we're seeing here. So we have a there's the Norman window. There's our window we have, and then I'm just gonna label each side with the variables. So this will be x, this can be y, and then to figure out this, what we can do here is, since this is x, that means this side is also x. So our diameter is going to be x, but our radius is half of diameter, so this is going to be x by 2. Now, since we have that done, we're going to make our equations. So I'll start off with making our area equation. So area is usually equal to length times width, but for now, we're just going to do x times y, and then we're going to have to add that with our semicircle area. That just gives us this area, but we also need to do this area. So we're just gonna do plus the semicircle area. A circle area is pi r squared, but since we have a semicircle, it's half of that, so it's gonna be 1 by 2 pi r squared. And our r is x by 2, so we're gonna replace r with x by 2. Let me do on the side, and then I'll just re-input into the equation. So 1 by 2 pi, and then x by 2, and then I'm going to square the whole thing, and then just I'm just going to simplify it by just solving for a little sorry, 1 second, squared 4, then I'm just going to multiply this. So now we're going to end up with this. I'll just clean it up and write it like this, so it looks a little bit more easier to read, right? That's our semicircle area. Now we're going to just input that back into this. So area is equal to xy plus pi x squared divided by 8. Now we're going to figure out our perimeter formula. We know that the entire perimeter is 20, so we're going to have 20 equal to, and then we have two sides are y, and then we're going to figure out the semicircle side and plus x. So 2y plus x is what we have so far. And now we need to figure out the semicircle, which is going to be the perimeter for a for a regular circle is 2 pi r, but since we have half of that, we're just going to write plus pi r, and r is actually x by 2, so we're going to have pi x by 2. That's our formula we have. Now we're just gonna if we look in our steps here, we said that we want to basically solve, we want one variable, right? So we input it into our next equation. So we're gonna isolate for y here. So 2y is equal to 20 minus x minus pi x by 2. And then divide 2 on everything is going to give us y is equal to 10 minus x by 2 minus pi x by 4. Now we're going to input this back into our area equation. So a is equal to x and then 10 minus x by 2 minus pi x by 4. Now what we can do is just do the rest of the equation, pi x squared by 8, and then we're just going to clean this up by writing it, by distributing the x. So this will give us 10x minus x squared divided by 2 minus pi x squared divided by 4 plus pi x squared divided by 8. These two are like terms, so I can add this up. If I just multiply this by 2, this will become 8, right? And this will give us 10x minus x squared by 2 minus pi x squared divided by 8. Now we could just differentiate this equation and then equate it to 0. So 10x is 10 and then minus x squared by 2. So if we do on the side here, 1 by 2, we're going to move 2 down here to our coefficient. That's going to give us 1 when we multiply it with the half. And then x minus 2 minus 1 is going to give us 1. So that's just going to be x. And then when we do this derivative, pi x squared by 8, it'll be 1 by 8 pi x squared. And then this square will be minus by 1. And then we're also going to bring that square down here. So this is going to be quarter. So we're going to have minus 1 by 4. Let me just write it cleanly. Pi x and then by 4. That's our equation we have now. Now we're just going to equate this to 0 and then solve for x. 10 minus x minus pi x by 4. And then we just can move the 10 to the other side and then divide it by -1 on everything. That will give us this equation here. Once we do that, we're just going to isolate x. So 10 is equal to x and then 1 plus pi by 4. And then we can just divide both sides by 1 plus pi by 4. This will cancel out and x will equal to 10 divided by 1 plus pi by 4. If we do on our calculator here, it's going to give us 10. It's going to give us, let me just do it real quick. 1 plus it's going to give us 5.6. So x is equal to 5.6 feet. Now we can just input this back into our equation with y. So y is equal to 10 minus 5.6 divided by 2 is 2.8. And then if we do that with this here as well, it should give us pi times 5.6 and then divided by 4 is minus 4.4 approximately. So 10 minus 2.8 and then minus 4.4 is going to give us 2.8. Now y is equal to 2.8. We have our dimensions as 2.8 and 5.6. And then we also need to figure out this dimension here, our semicircle, because that's one whole side as well. So pi r is what we need to just apply. So semicircle side is going to equal to pi times r, which is just going to be, let me just write it out here, pi r, which is going to be pi x by 2, and x by 2 is 2.8, so it's just 2.8 times pi So 2.8 times pi is 8.79, 8.8 approximately, and that is our dimensions. Now we're just going to figure out our restriction. So we know that x is greater than 0 and y is greater than 0, right? And now we just need to make an equation. So we'll be using this equation, y is equal to 10, and then minus x by 2 minus pi x by 4. And then if we rearrange it, so 10 minus x x by 2, and then minus pi by x divided by 4, we can then have this greater than 0, and then x can be isolated when we have, we'll move 10 to the other side, so it'll be 10 is less than x by 2 plus pi x by 4. And then if we just isolate x, it'll be 10 is greater than x. And then, this will end up actually being like this. Okay, and the x will be isolated, so 1 by 2 plus pi by 4. When we divide it on both sides, x should be, you're going to get x is equal, 1 second, let me actually just divide up both sides. 1 pi by 4. You're going to end up with x is less than 7.7, right? And then since we know it's greater than 0, it's going to be greater than 0. You're going to get that as your restriction. Okay, now we're going to be covering our second question. So the second question is saying a printer needs to make a poster that will have the area of a total area of 200 inches squared and will have 1 inch margins on the side and 2 inch margins on the top and 1.5 inch margins at the bottom. What dimensions will give the largest printed area? So we're maximizing area again here. So let's make a diagram and then we'll get to our equations. So we have a paper. Let me make that bigger. Let me actually remake that. We have a paper, and then it says that we have margins inside this paper, so we're finding the dimensions for the inside part. So we have a 1 inch margin here, and then we have a 1 inch margin here. So 1 inch, and then it says 2 inch margin at the top and 1.5 at the bottom. So 2 at the top and then 1.5 at the bottom. Those are our margins. So if we label this as H, this side was H, but then we're figuring out what this is. That's what we're trying to figure out. Let me use a different color. So we're trying to figure out this side and this side. Okay, so we labeled this side as H. We'll label this as W. Okay, so that's this current side right now. Right? But we don't want that. We want the inside margin sizes. So we could do H minus 2 minus 1.5. 2 minus 1.5 is 3.5. So H minus 3.5 is our inside length for this side. And now we need to figure out the same thing with the bottom. So W minus 1 minus 1. So that will give us 2. So W minus 2. Now we can make two formulas. So we know that width times height gives us 200 inches. So we'll write that here, because that's just the whole paper's area. So we're just doing width times height, and that gives us 200. And then if we do our second formula, it's going to be area is equal to the inside margin. So we're just going to be covering this only now. Okay, so that's going to be h minus 3.5 times width minus 2. And we've already figured out those dimensions when we calculated it, when we minused the margins from our original height and width. That gave us these new dimensions. Now, since we have these two formulas, we can isolate for one variable in the first equation, and then input the isolated variable in our second. So we'll isolate h. So h is equal to 200 divided by width. We divided width on both sides, so that gave us that. Now we're gonna input h again into this formula. So area is equal to 200 divided by width minus 3.5, and then multiplied with w minus 2. Now from here we're just going to expand. So we're going to use FOIL method here. This is going to give us, so w times 200, w is going to be just 200. And then 200 times minus 2 is going to give us minus 400. 400 over w. And now we'll do the same thing with the negative 3.5 on both. So negative 3.5 with w is going to be negative 3.5 times w. And then negative 3.5 times negative 2 is going to give us positive 7. Now, let's just clean this up. This is our area. If we clean this up, we're just going to add 7 to 200. Those are our only like terms right now. So area is equal to 207 minus 400 divided by w minus 3.5 times w. Now we're going to just differentiate this, find the derivative, and then equate it to 0, like we did earlier in our previous question. So the derivative of area is going to now equal to 200. The derivative of 200 is 0. So 0 minus the derivative of 400 over w is basically negative 1w. And then, actually, let me rewrite that. Negative 400 and then w to the power of negative 1. Now, when we take negative 1 to the bottom, it's going to become 400. It's going to become positive because negative 1 times negative 1 here, the negative here, is going to become positive. So 400, and then we minus 2 here. Not minus 2, sorry, minus 1 here. That's going to give us w to the power of negative 2. And then we can rearrange that when we bring it down back to the denominator. So 400 divided by w to the power of 2. So that's what we have for that different derivative. So 400, this will be positive, divided by w squared. And then we're going to now derive 3.5w, negative 3.5w. We're going to take 1 here, bring it down to the bottom. It's going to multiply by negative 3.5. It's going to stay as is. And then we're going to minus 1 with it. W to the 1 minus 1 power is going to just equal to w to the power of 0, which is going to be 1. So negative 3.5 times 1 is going to be negative 3.5. So now it's just a constant. So minus 3.5. This is what we have so far. So let me just clean this up and write 400 by w squared minus 3.5. And then now we can just equate this to 0. So 0 equals to 400 divided by w squared minus 3.5. We'll move 3.5 to the other side. So we'll have 3.5 equals to 400 divided by w squared. We'll multiply w on both sides. So 3.5 times w squared equals to 400. And then we divide 3.5 both sides to cancel out 3.5 and isolate for W. This cancels out. 400 divided by 3.5 is 114. So W squared is equal to 114.286. Okay, now we're just gonna square both sides. And then once we do that, we should get 10.69. So W equals to 10.69. That's one dimension we have so far. Okay. Now we're gonna solve for H. So we can just input that back into the easiest equation. So we're gonna input that into equation 1 here. So W is gonna actually we'll input into this equation. I'll make it easier since it's already isolated H. So 200 divided by 10.69 is gonna equal to H, which is gonna give us 18.71. Height is equal to 18.71. And the unit is inches, so we're going to write inches. And width is equal to 10.69 inches. Well, now we have both of our dimensions. So now we're going to just find our restrictions and just see if these dimensions work. Now we have W minus 2 is greater than 0, and if we move 2 to the other side, it's going to be W is greater than 2. And then we'll do that for H as well. This is for printed height and printed width. Then H minus 3.5 is greater than 0. So if we move that to the other side, it'll be H is greater than 3.5. And then now we're just gonna do that with 200 by W is greater than 3.5 because we derived H, it gave us 200 by W. So now I'm doing the same thing, but I'm just substituting 200 by W for H and having it as greater than 3.5. So once we do that, we're gonna have 200 is greater than 3.5 W. We'll divide W on both sides, 3.5 on both sides. That's going to give us the width. And the width is going to be 200 divided by 3.5 is, now we're going to have the width as 57.14. So the width has to be less than that. So it should be in between 2 and, yes, it should be in between 2 and 57.14. This is our restriction.